Okay, but now today we are going to start with 2018 IAL S1 paper. Right. Okay, we'll start with the first question here. A random sample of 10 cars. So when you look into this question, Pate, we need to understand that yes, n equals to 10. So we are, what do you call that? We have to understand these facts because when you're reading out the question, some of the information available in this much. Published in miles per gallon P and the actual miles per gallon M is recorded, right? The data are recorded using the variable X over P. So in this case, this is a coded value, Pate. It's given as a coded information. uh, X is P over 10 and Y equals to this. So anyway, we can use this one kind of later for our calculations. Show that SYY formula is, you can say SYY is summation of Y squared minus summation of Y whole thing squared divided by, in sometimes you remember that this square comes down to the numerator. It is 2628.25 minus summation Y. Summation Y, but in this case it's not given, therefore we need to find it. 30 plus 3 plus 22 plus 15 plus 13 plus 8 plus 15 plus 13.5 plus 3 plus 19, it's turned up into 141.5 with it. 141.5 whole thing squared divided by 10. That would be the value for SYY, right? So you can say 2628.25 minus 141.5 whole thing squared divided by 10. It's turned up to, yeah, that's the answer. So nothing to worry with this. 626.025. We need this much of a significant, that is why they have given this question. Find the product moment correlation coefficient between X and Y. We know that gamma formula is SXY divided by square root of SXX into SYY. SXY value, it's already given here, 74.664 divided by the square root of, you can write SXX is 9.25924 into, we already found this answer, 626.025. This square root comes to the whole thing today. So it's turned up to 74.664 divided by the square root of 9.2592 into 626.025. Then the answer becomes 0.980. 980, yeah, 1. Okay. Give a reason for support for the fitting regression model in the form of y equals to a plus bx in the data, because here you know that from the product moment correlation coefficient, it shows a strong relationship between x and y. Therefore, you can module a equation relating x and y. So you can say, since gamma shows a strong relationship we can form a equation relating x and y. That's the reason where we can generate an equation for this kind of information. Find the equation of
Sir,
equation. Yes.
sir, if
Yes,
it
Pate.
is,
Yeah.
sir, if it is negative, can we still form
Yeah,
a
yeah, yeah,
equation?
yeah. Obviously, it's not a problem whether it's a positive or negative. It's a very good question. Like, it doesn't make it's not a problem whether it's a positive or negative. Positive shows you it's a positive relationship. Negative shows you it's a negative relationship. If it is a positive, then you get a positive answer for B. If you get a negative for gamma, definitely you'll be getting a negative answer for B. That's the only difference. Other than that, whether it's a positive or negative, some up to some, usually we can generate like minus 0.6. If it is minus 0.6 to minus 1, you can do it within this range, and plus 0.6 to plus 1 also. Generally we generate a equation of regression line for this, but not for the figures. less than minus 0, sorry, less than plus 0.6, and in between plus 0.6 to minus 0.6, you want form a equation of regression. It doesn't make much of successful of getting an equation such way. That's a condition we have to understand. But if it is more than 0.6 or less than minus 0.6, we use to generate a equation of regression line. That is, we consider it as a fair enough figure, but obviously it come up to more than 0.8 means it has a very strong relationship. So we are not hesitating to form any kind of a regression line for that. That's a very good question for them, right? Okay. Find the equation of the regression line for x and y. Give your answer in this form. So in this case, you know that in this equation, b is equal to how much? Sxy divided by sxx. Sxy, yeah, we already found, here it's given 74.664 divided by sxx. Sxx we already found 9 point this bit. 9.25924. So you can get this answer 74.664 divided by 9.25924. That value become 8.064. Right. Then we can get the answer for y, a put. A is y bar minus bx bar. Y bar means summation of y. I think we already gotten summation of y. 141.5. 141.5 divided by 10 minus BB is 8.064 times of x bar. X bar is summation of x. Summation of x is not given over here. Therefore, we need to find the summation of x as well. The summation of x is 6.89, start this column, plus 3.67 plus 5.92 plus 5.04 plus 4.87 plus 3.92 plus 4.71 plus 5.14 plus 3.65 plus 5.23. It's turned up to 49.04. 49.04 divided by 10. From here you can get this answer. 14.15 minus BB is 8.064 into 4.904. That is turned up to minus 25.395. So it's A, doesn't matter, it's not B. So you can say y equals to A plus bx. So you can say minus 25.395 plus B is 8.064x. That's the answer for equation of regression line today. Right. Then they mention a car published miles per gallon is 44. Estimate the actual miles per gallon for this particular car. Right. A car published miles per gallon is 44. Right. So the miles per gallon, in 1 gallon, how many miles it can travel with it? It indicates by the gradient, right? So it's indicated by the gradient with it. So in this case, the gradient is the one which shows this miles per gallon. So anyway, what you need to do is initially with it, we need to form this equation with the exact information to find this value with it. So this is the exact facts. Exact facts. So what you need to do is we can replace with this with it. So I will replace with these the exact figures. So y is m minus 25. You can say m minus 25 equals to minus 25.395 plus 8.064x. Instead of x, you can replace p over 10 with it. P divided by 10. Right. Then we'll go ahead with this. Then if you just work out over here, m minus 25 is equals to minus 25.395 plus 0.8064p, right? Then if you get it here, m is equals to, if you brought it here, 0.395 plus 0. Yeah, 8064p, right? Over here, Pute, now the gradient is, how this is given, this factor over here, Pute, m is the random sample of 10 cars this much published for the miles per gallon p, and the actual miles per gallon is m, Pute, right? So this is the published miles per gallon and this is actual miles per gallon, Pute. The published mile per gallon is 44, that is p. Here, look at this. Published miles per gallon is published value is one, actual one is simple empathy. That from here, published one is 44. Then you can say actual one would be 0.395 plus 0.8064 times of 44. From here, you can get the actual amount over here. But you can say 0.395 plus 0.8064 into 44. It actually should be then 35.8766. That's the actual value for that. Comment on the reliability of the estimate in part E. Give your answer over here. So we have to see whether this is a extrapolation or interpolation. That's what we need to find it. So if it is 44, look at this. If I put 44 here, published one is data coded per variable is x. The published one is p. Then if I put 44 here, the answer is 4.4. Right? If you substitute in, because like because there's a coded information. So if the p value is 44, what is the x value relevant for that p is? So you can say for p equals to 44 means relative x value is 44 divided by 10, that is 4.4. Now check whether have you calculated this information within this range. Here the range is from where to be up there. So we already gotten the value from 3.92, 3.92 to 6.89. So this 4.4 is within the range we calculated the data. Understood? So you can say this is within the range, within the range of data calculated. Data calculated method, simply we can say this is called interpolation. Interpolation. Therefore, what you can say, therefore, it is reliable. It is reliable. That's a way of writing this answer.
So,
When you refer this question, two youth club, Estriu and Westriu, describe the raise the money of charity by running a 5-kilometer race. All the members of the youth clubs took part and the time in minutes taken for each member to run in 5 kilometers were recorded. So Westview Club, it was recorded over here. Write down the time which exceeded by 75% of the Westview numbers. So like that, write down the time that exceeds by 75% of Westview members. So in this case, more the higher, like exceeded by 75% of the members. But the 75% of the members means it is first quartile or the third quartile. This is a little bit of a doubtful question. Just think of it.
so the third one.
Yeah. One second. Right. One second. Sorry. Just kind of discrepancy comes. Right. Okay. Write down the time taken exceeded by 75% of the waste to make. Can you like 75% people should exceed this time limitation. Okay, that means here in this way, like you need, but this is the point to understand that with the exceed by 75% people. But that time should be here 25%. This is the third quartile, but only 25 is exceeded that time. 25% of people were exceeded this time duration. From here to here, another 25% was exceeded. From here to here, another 25% is exceeded. Therefore, what is the duration where the 75% exceeded? It's a value over here. It should be how much? Roughly it's turned up to 29. 29 would be the answer for this question. Understood? That's how you need to work out with this. Yeah.
So why can't we go from Q1 to Q3, taking
Sorry.
25%?
Yeah, it's a very good question. So if look at this, they mentioned that this is the time taken by the different kind of a people. Okay. So in this case, the minimum value is how much? 20 something minutes, right? Okay. But you know that the least up to here only 25% was only 25% was exceeded. Sorry. Only what do you call that? This is the time duration. Like look at this. When you're working out with this, you can say this is the highest time taken for this. From here above, there are no people were there. There were no people were there. So from here to here, how many people were there? So you know this is 25% because it's first quartile. Sorry, this is a third quartile. Third quartile means it's only 25% people were taken the time more than this. It's exceed. Look at this is the point to understand that. Exceeded by the highest time taken. Like this is the highest time taken 25%. This is the next highest time taken by next 25%. This is the next highest what do you call time taken by next highest people. So they were exceeded by 75. The majority of the people should be delayed more than that. That is what you mean by 75. So in this case, 25% delayed over here, another 25% delayed over here, and another 25% delayed over here. So from here only you get what exceeded by 75. That's the reason for you need to make it because from the question only you need to understand this situation. Okay, right. Okay, the time for each two members are summarized by the stem and leaf diagram below. The stem is given and the leaf value also given. Find the value of the median and the interquartile range of the each two members. Right. To find it initially, we need to find median. Median is n divided by tooth data. N divided by tooth data. How many information over here? 11, 25, 30. 30 divided by 2 is 15 data. If you get an integer value, what you need to get? You get the 15 data plus 16 data divided by 2 would be the median for that. 15 data. Up to here 11, 12, 13, 14, 15. 15 is 30, 16 also 30, divided by 2, answer is 13. Then if you get the Q1, Q1 is equal to 30 divided by 4. Data that is 7.5 data, that is 8 data. If you get a decimal answer, you get the 8 data. 4, 5, 6, 7, 8, 28. 28, Q3. Q3 is 3 times of 30 divided by 4th data. That is 22.5th data, that is 23rd data. See whether where the 23rd data is. 23rd, 11, 12, 13, 14, 15, 16, 17, 18, 21, 22, 23. 23rd data is 32. Is this which IQR is equals to Q3 minus Q1. That is 32 minus 28, it's turned up to 4. Okay, an outlier is value for false either more than 1.5 times of Q3 minus Q1 above Q3 and 1.5 times below Q1. The same condition over here we need to work out with it. To make up a workout color, if you get into this much, lower boundary. Lower boundary is Q1 minus 1.5 times of IQR. Q3 minus Q1 is IQR. The Q1 value we know. That means here they have given the usual formula for the range of 1.5. Q1 is 28 minus 1.5 times of IQR. We already found it as 4. Yeah. So it's turned up to how much? It's 22. Now this is the point to understand that today. In this stem and leaf diagram, now check whether there are any values less than 22. Yes, we have a value less than 22. Therefore, lower boundary is 22 and 20 is an outlier. An outlier. Upper boundary. Upper boundary is Q3 plus 1.5 times of IQR. That is Q3 is according to this one. Q3 is 32 times 4. It's done up to 38. 38. Now check whether, yes, from this side even, there is an outlier. So you can say upper boundary is 38 and 39 is an outlier. 39 is an outlier. Okay. Then sketch, sorry, on the grid on page 7, draw the box plot. So you can draw the box plot over here on page 7. Okay, then according to this one, lower boundary is the lower boundary is 22 and upper boundary is 38. Lower boundary is 22 and upper boundary is 38. So I'll just mark like this. Lower boundary is 22 and 38. 22 and upper boundary is 38. And I can mark the outliers. Outliers are 20 and 39. 20 and 39 outliers. 20 and 39 and outliers. So the quartiles, the quartiles are 28, 32, 28, 30, 32. 28, 30, 32. This is how you can understand with this. So then what you can, then what they want is they mention state the skewness of each distribution, give a reason for this. So what you can understand is the gap between Q1 to Q2 and Q3 to Q2 is same. Therefore, it's symmetrical. Therefore, the answer for part D, you can write in this way. You can say Q3 minus Q2 is equals to Q2 minus Q4. Therefore, we can decide as symmetrical. That's a way of getting the answer for this question. Right. So this is how, according to this relationship, I think it's clear with you. 0.4 from R company, 0.25 from S company, and rest. Rest means out of 1, if you subtract this 2, you get this one answer. These are the probability of being faulty of these ones, right? Okay. The first question is, draw tree diagram, calculate the probability of engine company R and it's not faulty. It's R and not faulty. It's not faulty means a good one. It's a company R and it's a good one. That's how it comes. Okay. Then that is 0.392. Calculate the probability that engine is faulty. The faulty combinations are these ones. These are the combinations of being faulty. This is a one combination, and this is another combination, and this is another combination. So if you come up with this, those are the 3 combinations. Then if you come over here, so you can say the probabilities would be 0.4 into 0.02 plus 0.25 into 0.01 plus 0.35 into 0.02. That would be the answer for that. It's not 0.4 into 0.02 plus 0.25 into 0.01 plus 0.35 into 0.02. That become 0.0175 would be the answer for that. Given that engine is this is one now come up with the conditional probability. It come up with the conditional probability. We'll see how to answer this question today. Right. Then how to do this today? Like we'll try to work out this question today. Here given probability of, then you have to write the given probability today. It's given it's faulty. Given that engine is faulty F. Find the probability that engine did not come from S, it's S dash. Then we have to work out it clearly. Probability of S dash intersection F divided by probability of F. So the S dash F means it's not S, but it's faulty. What are the combinations with it? It's being R and faulty. It's S, it's not S. T and faulty. S with faulty, S with faulty, sorry, S not S, R with faulty and T with faulty divided by total faulty. So R with faulty is 0.4 times of 0.02 plus T with faulty is 0.35 times of 0.02 divided by total faulty for probability we already found from here. 0.0175. Then you can say 0.4 into 0.02 plus 0.35 into 0.02 divided by 0.0175. You get the answer 7 over 6 per day. 6 over 7, sorry. 6 over 7 would be the final answer for this. Right. A discrete random variable x as a probability function. It's like it's given as a probability function. Show that k equals to 1 over 9. The simplest way is we know that if you add up all these probabilities, that should be equivalent to 1. That is a theory we use to find this one. So I'll just get these values x. The probable x values are 0, 1, 2, 3, and 4. Then if you come up with their respective probabilities, it's just like this. If you get the probability of x equals to, if it is 0, you can use this. That means if you replace 0 over here, x2 minus 0 is 2, k into 2 is 2k. This is 2k. If I put 1, 2 minus 1 is 1k. If I put 2, 3 minus 2 is 1, it's k. If I put 3, 3 minus 3 is 0, it's 0. There is nothing over here. If I put 4, 5k. Then you can say 2k plus k plus k plus 0 plus 5k equals to 1. Therefore, k equals to 1 over 9. From here, you can get this answer. So, simply this is turned up to 2 over 9, 1 over 9, 1 over 9, 0 and 5 over 9. Those are the probabilities over here. So, if I use a different color to represent those probabilities, this is 2 over 9, 1 over 9, 1 over 9, 0 and 5 over 9. These are the probabilities. Right, let's go ahead further. Right. Find the exact value of probability of x is greater than 1 but less than 4. Less than 4 means 4 is not included. There is nothing called 2. X equals to 2 plus 1 is included over here. X equals to 1. Therefore, it's turned up to k plus k, 2k. 2 over 9 would be the final answer for this. Expectation. It's pretty simple. We can find the expectation by this number by, how to get the expectation over here? This number by this one with this one with this one with this one with this, and you can add them together. Right. You just work out. Here it's 0 into 2 over 9 plus 1 into 1 over 9 plus 2 into 1 over 9, 3 into there's nothing, 4 into 5 over 9. So it's turned up to uh, 1 plus 2 plus 20 divided by 9. It's turned up to 23 over 9. 23 over 9. Then ex squared. How to get ex squared? 0 squared into 2 over 9 plus 1 squared into 1 over 9 plus 2 squared into 1 over 9 plus 4 squared into 5 over 9. So you get the answer. This is 0 plus 1 plus 4 plus 5 over 9 today. 5 over 9. Then they want to find out the variance of 3x plus 1. Initially, we can find the variance of x. What is the variance of x formula? Ex squared minus ex whole thing squared. So 3x squared is 85 over 9 minus 23 over 9 whole thing squared. 85 over 9 minus 23 over 9 whole thing squared. It is 236 over 81. That is a variance of x. Then f. If you, sorry, not f, sorry, actually, if you need to find the variance of the formula for this, ax plus b, answer is a times a squared times of variance of x. But the plus b doesn't make an impact on that. So therefore, if you need to find the variance of 3x plus 1, it should be 3 squared into variance of x. That is 9 times of 3, 236 over 81. That is turned to 236 over 9 would be the final answer for this. That's a way of doing this. If you just come up with this, it's other way of getting this. The weight in grams of random sample of 48 board beans are summarized in the table. That means here, there are 9 beans in the range of 0.9 to 1.9, and the other one also started with 1.9. This is the important points we need to be verified. Therefore, no need of defining class boundary for this. No need of rearranging the class boundaries because there is no gap between this. So you can start these ones over here. Right? Now you can see here the gap is 0.2. 0.2, 0.2, 0.2, 0.2, 0.2. But here it's kind of changed, 0.6. As a result, when you draw a histogram, though you mention a histogram, straightforward, we can't draw histogram for this. What is the reason? Because the class boundaries are different. But there are some situations whether the class boundaries are similar, even we, rather than the drawing a histogram, we used to draw the frequency density table. What is the frequency density? Formula. Frequency density is equals to frequency divided by class width. Class width is lower boundary minus upper boundary. Upper boundary minus lower boundary, sorry. Right. Then they are referring to 2.1 to 2.7. That means they are referring to this one. And we need to find the information for this category. This is the one we are going to find it with. So I'll just different color for this. Then this is the way. Initially, we know that the information here is 0.6. The width. I'm worrying about the width. Width. For this category, width is how much? 2.7 minus 2.1 is 6. 0.6. This 0.6 is indicated by a width of how much? 1.5 centimeters. 1.5 centimeters. Then we need to find what is the width you need to define for this one. So you are using the same scale. Here the width is how much? 0.2. A width of 0.2 should be represented by what kind of a length? That is the fact we need to work out. If you work out with this, W should be 1.5 into 0.2 divided by 0.6. It's turn up to how much? 0.5 centimeters. That is the answer for that question. Then height. When you define a height, we need to find the frequency density for this. How to find the frequency density? 9 should divided by class width over here. 9 divided by, how to calculate the frequency density here? 9 divided by class width is how much? 0.2. The frequency density is 45. Here the frequency density, how to get it? 2 divided by 0.6. 2 divided by 0.6. That is 10 over 3. So since this is just like fractional mode, we just work out here. Height 10 over 3 is represented by a height of how much? By a height of 1 centimeters. We need to see whether then for a 45 height, for a height of 45 is represented by what kind of frequency? 45 represented by a height of how much? H. So you can say H is equals to 1 times of 45 divided by 10 over 3. 45 divided by 10 over 3. It's turned up to 13.5 centimeters. Okay, that is the answer for first question. It's a little bit of a calculation, but very pretty simple calculation. So you need to work out with that. Give a reason to justify the use of histogram to represent. Give a reason to justify the use of histogram to represent this data. Right. So what can you say with it? So you can see this information, what you call the set of information is continuous, right? Usually for a continuous, what do you mean by continuous? There is a continuously, the information was scattered. There is no gap between these ones because they are continuous. Because for a continuous information, we can use a histogram to represent this data because it is continuous. Continuous, right? Okay, see, right. Estimate the mean and the standard deviation for this weight of board of the beams, right? So the mean, how to get the mean for the mean x bar is, we need to work out summation of fx divided by n, summation of fx. Here it's y, summation of fy divided by summation of fo n. Summation of fy, how do you get it? You have to multiply this category. You have to make fy column over here. 9 into 1, f into y, f into y. So you can see my arrow, 9 into 1, it's 9. 12 into 1.2, 14.4. 11 into 1.4, because there it's not given, so we have to work out with that. 1.4 into 11, it's turn up to 15.4. 15.4, 8 into 1.6. It's 12.8. 12.8, 3 into 1.8 is 5.4. 6.0, 4.8. Therefore, you can get the summation of fy column by 9 plus 14.4 plus 15.4 plus 12.8 plus 5.4 plus 6 plus 4.8. Turn up to 67.8. 67.8. Therefore, you can get 67.8 divided by number of information. No need to add them together because you already know it's 48 divided by 48. Now you get the answer. It's this big today. 1.1425. Now see whether 1.14 is in somewhere over here. Somewhere over here, which is relevant for the highest frequency. Usually, we know that mean is fall comes to a figure which is close by to the highest figure. So there's it's reasonably that is fine for that, right? Then the standard deviation for that, right?
Sir?
Yes, for that.
Sir, the mean I get 1.4125.
Yeah, sorry, 4125. Sorry, it's correct. Sorry, I made a mistake. 4125, 1 point. Yeah, it's here. Yeah, that's it. Not 144. Right. Then standard deviation. Straightforward, you can't find the standard deviation. Initially, you have to find the sigma squared variance. That is summation of square divided by summation of f minus divided by a whole thing squared. So that over here, we can get this answer. It's already given, on it of worrying to find it again. 0.56 divided by 48 minus this value we already found from here. 1.4125 whole thing squared. Then we can work out with that. 101.56 divided by 48 minus 1.4125 whole thing squared. Yeah, that's done up to 0.12. With this, you can get the sigma. Standard deviation is the square root of that answer. 0.12, that is turned up to 0.347 is the standard deviation for this question. Right. The next question is we need to use a linear interpolation to estimate the median weight of this one. To find the median, we need to work out, that median is n divided by 2th data. N is 48 divided by 2 is 24th data. Now she had to check whether the 24th data falls into which category. You know that to find it, we need to make another column called the cumulative frequency. Yes, I draw it here itself, cumulative frequency here. You can get 9. 9 plus 12 is 21. 21 plus 11, 32, 40, 43, 43 and 40, sorry, 45 and 46, sorry, 46 and 48. Now we need to physically understand what do you mean by this 9 stands for. 9 stand for the first information to 9th information is in this category. This 21 stand for 9th information to 21st information is in this category. This 32 represent 21st information to 32nd information is in this category. That's a factor to understand. Therefore, 24th falls into which category? It's here, can I over here. Then we use a linear interpolation method. We know that 24th data is in between where to where. It's in between 21st and 32nd. Therefore, the median falls in between 1.3 to 1.5. Then we will use this gap divided by this gap is equals to the same thing for the top part of it. 24 minus 21 divided by here. That's a method called linear interpolation. From here you can get the answer for n. So it's done up to 4 minus 21 is 3 divided by 32 minus 21 is 11 into 1.5 minus 1.3 0.2 plus 1.3 would be the final answer for that. Therefore, the median turn up into 1.355 is the answer for median.
Sir?
Yes.
Sir, instead of writing M, it's okay to write Q2, right?
Doesn't matter. It's not a problem at all.
Sir, I'm done.
Yes, right. So we can get the median over here. Then the next part of the question is it's just like this. Yeah. So that is what we find. Median, right? Okay. One of these beings is the selected random. Estimate the probability that weight is lie between 1.1 to 1.6. Right. Let's go ahead with that question. It's in between 1.1 to 1.6. It's come up over here. It's 1.1 to 1.6 is here. Somewhere in between this. Then we can see if you answer the question, answer for question number E. Question number E. You can see 1.1 to 1.3, there are 12 information. 1.3 to 1.5 in this gap, there are 11 information. Now you need to see whether 1.5 to 1.6 put it. 1.5 to 1.6, how many informations are there? You know that 1.5 to 1.7, there are 8. 1.5 to 1.6 is half of that range. That is turn up to half of this. It's turn up to 4. Totally how many information available then? 12 plus 11 is 23, 27. Divided by, asked about the probability, divided by total one is 48. So this would be the answer for that. 27 divided by 48. It's turn up to 0.5625. That's the answer for this question. Right. Then the next part of the question. Here. One of these board beans having recorded the weight of 0.95 grams was incorrectly weighted, and the correct weight is 1.4 grams. State giving reason the effect that would have on your answer in C. Do not carry out any further calculation for this. Do not carry out any further calculation for this. So you need to work out using these ones for this. Right. Right. Then 0.95 extended by 1.4 in part C answer is estimate the mean and the standard deviation, right? Okay. Now you can see, but this is the situation. X bar is 1.4125. Now it is corrected like this today. 0.95 was removed and added a more value than that today. Therefore, for the total count, 0.95 was, it's a wrong way, correct, what do you call counted. It's a wrong count, but the correct answer is 1.4. Therefore, when you remove the 0.95 and when you add 1.4 into this, for the final answer, what is the X bar solution for the summation of X divided by N? Therefore, for the summation of X, 0.95 is removed and 1.4 added means another, for the total count, another 0.45 was added. N is same thing. Therefore, what you can understand that the total count would be high. As a result, what happened to the mean? The mean would be a higher value. So, giving reason. So, you can say when 0.95 is removed and 1.4 is added, extra 0.45 added to summation of fx. Therefore, what happened to the mean must be increased. Mean must increased. Mean must increase. That's the answer for that. Then what is the impact on standard deviation? Yeah, that is the fact we need to understand from this question today. Now, what you can do here is today, the mean is 1.41, the mean is 1.41. You remove a value which is so far away and you add a value close to this mean. What is the definition of the standard deviation? That is the average variation from mean. It's average variation from mean. You remove a value which is far away and you add a value very close by. Therefore, what happened to the deviation today? Deviation would be much narrower because the added information is a value which is very close to the mean value. So you can say, how to write the answer for this question is a faraway value from mean has removed and a value close to mean is added. Therefore, sigma must get lower. That is the answer for this question.
Next meeting is being recorded.
Yeah, right. The waiting time L in minutes to see a doctor at a health center is the normal distributed with mean, mu and standard deviation of sigma squared. Given that probability of L is less than 0.1, sorry, less than 15 is 0.9 and L is less than 5 is 0.05. Right. Find the value for mu and sigma. Right. We'll work out and see. Then initially what you can get here is that we need to find the sigma and mu. So the first information I'm referring to less than 15 is equals to 0.9. Then first of all, we need to make them into standard normal. Therefore, this L side turn up to Z is less than 15 minus mu divided by sigma is equals to 0.9. Now let's try to understand. Let's try to get this figure. Uh, get our S1 book. Right. Then less than value of 0.9, we need to read it from the table. Either you can use this value, less than 0.9. 0.9 means 9,000. See whether what is the event relative for 9,000. Here you can see there are two close value. 1.28 is there and 1.29 is there. So out of these two, the closest value is 1.28. This is, you can say 15 minus mu divided by sigma is the closest value is 1.28. Or sometimes you can use this technique as well. But under here, there's another table today. This table indicates you the greater side region for one couple of values only today. If the lesser region is 0.5, what is the greater region today? If the lesser region is 0.9, the greater region should be definitely 0.1. Then method just check from the probability whether you have the 0.1 value. Yeah, it's here. You can find the value from here. So the correct answer is 0.2816, but nothing to worry. If you don't know how to get this read, you can get this one even. You can get the final answer. It doesn't make a big difference for the final assumption. So therefore, you can use this one as well. That's the first part of it. After the second part of the question. So you can get like this. Probability of L is less than 5 is equals to 0.05. Initially, we'll make them standard normal. Z is less than 5 minus mu divided by sigma is 0.05. Now let's see whether from lesser than 0.05 is not there, but for the greater side 0.9%, it's not there. Right? Okay. Then what you can get here is for the lesser region, it's correct. But our doubt is what? Because less 0.05 probability is not available. The least probability is how much? 0.5 only. To answer this question, what you can do is we use another technique. This is lower side, you can read the table, but this value is pretty small. Therefore, we get 1 minus 0.05 and we read the probability for that. 9,500. 9,500 you can get any of these figures, whatever it's called, because like it's the same thing over here. We can use any of these two. Out of these two figures, I'll get 1.64. Therefore, you can write 5 minus mu divided by sigma is minus 1.64. Why it's minus? Because you know that for the lower side, it's a very small value. Because of that, I just got 1 minus of this answer. When you're reading it, you have to put a minus for that. From this equation, you can generate an equation. 15 is equals to mu plus 1.2816 sigma. From here, you get the answer mu minus 1.64 sigma equals to 5. Then I'm going to simplify these two as simultaneous equation. If you solve this, you get the answer mu and sigma. I will use the get the help from the calculator to answer this question. The simultaneous solutions. It's 1.2816, and the answer is 15. Here it's 1 minus 1.64, and answer is 5. So one answer is put mu is 10.61, 10.61, and sigma become 3.42. Initially, that is the way of starting this question. Right. Now you know that there are 23 waiting to see the doctor in the health center. Determine the expected number of people who will have waiting time for more than 12 minutes per day. So what you need to find here is we need to find the probability of being lie time is greater than 12. Initially, we need to find this factor. What is the probability for that? So you can write initially make them into standard normal. 12 minus the mean value is 10.61 divided by the standard deviation is 3.42. It's turn up to probability of Z is greater than, you just work out 12 minus 10.61 divided by 3.42. That is 0.42. 0.41, sorry, 41. Then we can find, because we can't find the greater region from the table, it should be 1 minus probability of Z is less than 0.41. That is 1 minus less than 0.41. That is 4141. 6591. 1 minus 0.6591. Standard 0.3409. And then we can get the number of people. This is a probability. This happens from out of 23 people. 23 into 0.3409 into 23. 7.8. 7.8.
Why do we multiply it?
Because with the out of 23 people, they ask what how many people we expected to happen today. The probability of B more than 12 is how much? Out of this Q should be a probability of 0.3409. So that is probability of being a person get a delay for this process. So out of 23 people, they ask for how many people you expect to be delayed. So it will be around 7.84 means you can say it's roughly 8. Yeah. You repeat with this, that is how you need to do it today. So initially, PA 0.5 means this region is 0.5 addition of these two. A given B is 2 over 3. Therefore, that is, you can say A intersection B divided by PB. 2 over 3 is A intersection B. How do you get the A intersection B? From this information by repeating. A complement union B complement. It's outside A with the black color colored ones, and B complement is outside B, the red color one. Union means our entire colored region. That region is 0.6 means except this one, other should be 0.4. Therefore, this intermediate region should be 0.4. From here, you can fill up that. And with that, you can get the value of 0.6. Then, if this total is 0.6, if it is 0.4, this should be 0.2. And we can mark the rest of the elements outside here even. 0.3. Yeah. From there, you can find the rest of it values. Initially, we'll fill up this. If I mark the A complement today, this is what. So I just consider this is A and this is B. It is A complement. Then B complement. B complement means outside B. When you color these ones, ignore the other part of it. We are just coloring A complement and B complement. Later on only we can see whether what are the intersection or anything we can refer with that. I just color this one. This is the B complement. Right? Then they are referring to A complement intersected by B complement. Intersection means the cross lines. Now you can say here only red, here only black, here there is nothing. You can see this is the region where you can see this cross line. This region. What is that value for this? That value is 0.3. And B complement means outside B. This outside B is outside from 0.4 and 0.2, it's 0.6, it's 0.4. That's how it comes.
Sir, can you?
Yeah, shall I repeat it again?
Yes, sir. Can you explain it,
Yeah, that's
please?
great. Okay, got this. Right. Then I'll erase this bit further. Yeah, this is what I'll just erase this bit of it. Right. Then prior to this one today, we already knew this value is 0. Sorry, I'll just use the black color for that. It's already there. 0.3 is here. And what was the value over here? But I can't remember.
0.2.
The value over here, this region.
0.2.
Sorry? 0.4.
0.2. 2, sir.
0.2. Yeah, 0.2, right. Okay. Now, what we need to do is, this is the theory we need to understand. Now, they have mentioned probability of C 0.55, A and C are mutually exclusive. Mutually exclusive means it's not A and C does not meet each other. Therefore, C should be a value somewhere over here. I think that point is clear with you. Right. That means then now, this what you can understand is this bit. Now you know that they have given B and C are independent. But if the B and C are independent, what you can say? B intersection C should be similar to probability of B into probability of C. Right. The probability of B intersection C, we don't know. Probability of B, we know that 0.6 in previous question we already learned. And PC is 0.15. Then this value is how much? 0.09. Then we know that this region is how much? 0.09. Right. Then we know that this 0.2. The 0.2 is a whole region over here. Then out of this 0.2, now what happened to it? 0.09 consumes over here. Then what would be the value over here then? Let's turn up to how much? 0.11. Is that clear, that point?
Yes, sir.
Then we know that PC is 0.15. This whole circle is 0.15. If this is 0.09, it's turned up to 0.06. Now we know that this 0.06 is in this range. It's consumed part of this value. Then what is the remaining value over here? Except this one. The other region is 0. Turn up to 24. Why is that? Because 0.3 is halting. It's halting over here. Out of this 0.3, this part is 0.6. Therefore, the outermost region should be then turn up to further 0.24. From that is the final answer for this question. That's a way of getting this.